Hi everyone, welcome to our project. This project is done by Yiting Gong and Yisan. This project analyzes flight insurance premium pricing factors, and we will go through the following sectors. As the first one, business understanding. Second one, data understanding presentation. Third one, modeling evaluation, and fourth, deployment. Let's talk about the background and objectives of a bank's business. So, insurance is one of the important sources of profit for the A bank. The insurance department wants to extend its existing retail insurance market, especially on the flight delay insurance. And the business objective is mainly the company wants to promote its flight insurance, and they have an idea of setting up automated vending machines in major airports next to the check-in counter so that people can buy before they check in. And a bank wants to increase the flight delay insurance revenue on the insurance premium income, while minimize the probability of the insured person's claim. In other words, they want to have a more accurate pricing model and also real-time updated pricing model for the pricing premium. Also differentiates the insurance policy in between the customers. And the success criteria will be as following 2 points: improve the insurance profit model, and to increase the profit and revenue by 15% in flight delay insurance sector. So let's have a look at the data that we have. So because of the limitation of the budget and the time, we collected the data from online open source. The data contains 1.9 million samples with 30 attributes. Data includes the nominal and continuous and discrete types of data, which is collected by 2008, but it was all year sample of 2008, which contributes a lot sample size to this project. And the data quality is relatively good. Missing value are in a controllable proportion. There are some noises and extreme values, but during the inspection and cleaning of the data, we have deleted most of them, and no duplicated values were found. Okay, let's have a bit overview of the data. So these are the basic attributes and how the data looks like, mainly from the original data. So it's ordered by timeline. As you could see, the year and month is ordered from the very first delay. And discrete attributes including month, day of the week, arrival, departure time, and distance of the flight. Nominal attributes include unique carrier name or code, flight number, tail number, departure and destination, departure origin and destination, and cancellation code. Interval data, which is continuous data, includes arrival, departure, delay time. There's also some problem with this data. The attributes of the data is not that many for a data mining scope method, and also as well as the data that we have is only recorded the ones has delayed. So the, the the flight on time was not recorded, so we cannot actually analyze what reason caused the delay or what factors caused the delay. The only thing that we can investigate in is to see what factors possibly influenced or increased the time of delay. After cleaning, we retain 0.9 to 1.2 million samples in the subsets we have, and all the missing data was removed. We raised the following questions because when we were exploring the data and visualizing the data, we found some patterns which we want to look at, especially as listed, because of and also needs to be mentioned that because of the time limitation and the things that we only considered are these following two, but really a lot more can be looked at deeper from this data set. But mainly we raised these four questions: relation between the distance delay, relationship between the weather condition and delay, a relationship between delay and day of the week, month, the relationship between airline and delay. As I've mentioned at the data understanding part, because the data that we have only contains the delayed flights, not the not delayed one. So to look at the reasons why it delays is not impossible from this data set. And again, our aim is to see if the factor is statistically significant, to be which can be included in the insurance pricing model as a factor in the future. So mainly we did a statistical test. Okay, the first one, distance and delay. We did a linear regression to fit the data with the model, and we got a very significant, which is close to zeros, p-value, but the R square we can notice is relatively small, which meaning the variance of the delay is not explained that much by the distance, but again the distance has significant effect on the delay, but it's not not powerful explanation. So we looked into the second one, which is the weather condition and delay, and we found really linear or correlated relationship between these two variables. The p-value is close to 0, which is good, and the R square is close to 90%, which meaning the weather delay actually explained close to 90% variation of the departure delay, and this variable is going to definitely be included in the final pricing factor. And we then looked at the if there's seasonal patterns in the month delay and the day of the week delay. We can see this one is the mean distribution of the and this part is the monthly delay. Say we plotted it as a sum of the delay variable, and the x-axis is the timeline from the beginning of the year to the end. very obvious seasonal pattern could be observed, and then we performed both of them. We performed an ANOVA test to see if the day of the delay and the day and the departure of the delay are actually independent, and same with the mass and arrival delay. All the p-values suggest that significant not in, so which meaning they are actually dependent. And let's look at the number 4 question, airline carriers and the delay. From the sum of the carriers delay, we could see several airlines has definitely a higher probability, higher delay time, total delay time. And then when we look at the distribution of the carriers delay, and we tested the mean and the distribution of the carriers and the delay time p-values among those, so which meaning the carrier and departure delay are actually dependent. So in the end we are going to include this as a factor into the final pricing model. Deployment. If everyone can have a look at our work of the report, we have a organizational structure as listed. So when we're deploying our project or our plan, we actually need to get proof from the compliance department first, and after their approval, we can proceed to the actuarial team to propose our new factors to them for like mathematical pricing model, for a new mathematical pricing model, and then the retail department is going to be the main pusher for this project. And also it is worth to talk about a bit about the monitoring and maintenance. I think it is important to keep track on the validation of the parameters that we have found, and also there's some further suggestions to the future studies, because the variables that we have looked at is too simple, I would say, because of the time limitation. There's definitely a lot more can be studied under those variables, and definitely there's more variables could be found. And in the future, the data collection can be spent more time on. The effort on the data collection is definitely going to be more, because as the data that we have only has 30 attributes, which mainly include discrete, nominal, and continuous variables. And also the data only contains the delayed flights information. The not delayed also can be included for a say logistic or labeled machine learning study. Okay, yeah, mainly that's our project. Thanks.